So let's plan for our future, all right? Be able to discuss the environmental and economic options in planning energy for our future. And let's consider some challenges of these renewable energy strategies. Although renewable energy is more sustainable energy choice than non-renewable energy, using any form of energy has an impact on the environment. Like biomass, for instance, is a renewable energy source only if it can be used sustainably. Over harvesting wood tends to lead to deforestation and degradation of the land, and we've seen all that before, like in Haiti. And wind turbines, they can basically kill birds and bats, and so who wants that? A hydroelectric turbine kills millions of fish. And manufacturing photovoltaic solar panels requires the use of toxic heavy metals and a great deal of water. So, because of all these energy choices have some sort of drastic environmental consequence, minimizing energy use is thought to be the way of conservation and efficiency. And it is the best approach to energy that we have. So, in order to achieve that, we need to make wise choices when it comes to energy and depend on a variety of environmental and economic and convenience factors to get there. Our energy future depends on efficiency, conservation, and the development of a renewable and non renewable energy source. All right, so energy experts suggest that innovations and technology advances will happen, and so the depletion of resources will not happen because humans are super smart. But there's no single energy that can replace all of this non renewable energy resources in a way that is complete. So that renewable, non polluting, free stuff, can take hold, but that stuff also impacts the environment. All right, so a sustainable energy strategy must have energy efficiency, energy conservation, and the development of both of those things, renewable and non renewable energy. Does that make sense? It has to include all those things to make sense. Despite the tremendous potential however, of these renewable energy strategies, the renewable energy resources are unlikely to replace those of fossil fuels in our immediate future anyway, unless the nation commits to some sort of supporting development. And we're only going to get that through direct funding, like financial incentives to the taxpayers, or like tax cuts, or some sort of like consumer rebate, which I don't see happening anytime soon. In fact, the U.S. Department of Energy predicts that fossil fuel consumption will continue to increase in the U.S. Well into the middle of the 21st century. So, this is something you may not see in your lifetime. In spite of their extremely rapid growth, wind and solar energy still account for far less than 1% of all the energy that we produce in the U.S. And government funding, on the other hand, here, those sources of capital and need to support research to overcome this current limitations that we have of many renewable energy sources are not available. All right. So one limitation that is already evident that is related to this transmission of renewable electricity over the electrical distribution network is just that cost. So um, that's something to consider. Energy cost, and the second one would be storage. I feel like I'm rambling, so I'm going to get to the point. Many people are focusing their attention on improving an electrical grid to make it efficient as possible and moving electricity from one location to another. Thereby, we're going to reduce the need for some sort of storage capacity. But an energy economy based on non-depletable energy sources requires reliable electricity storage, and it also needs to be affordable. So we have price and storage, or at least it needs to be effective and efficient, however that works. The U.S. energy scientists, they basically maintain that because we currently do not have a very cost-effective, reliable means of storing energy, that we should not depend on these intermittent sources like wind and solar energy for more than like 20% of our total electricity that we need to produce. So one solution that is currently in development may be what we call the smart grid. Love their title. They're just so intuitive. All right, a smart grid is a self-regulating electric electricity distribution network that accepts any source of electricity and distributes it automatically to its users. So, a smart grid uses computer programs and the internet to tell electricity generators when electricity is needed and electricity users when and where they can access the actual grid system. So, in this way, it basically coordinates energy use with energy availability. So, in late 2009, President Obama announced a plan to invest 3.4 billion in this smart grid technology. Since that time, industrial contributions have brought the total investment to like $8 billion. Surprise, surprise, they spent more money, which has been used to fund roughly about 100 or so smart grid projects around our country. So, how does this smart grid system work? So, if you look at the picture here, it shows just one example. With smart appliances plugged into a smart grid, at bedtime, a consumer could set the appliances like the dishwasher to operate before he wakes up and the following morning. So, a computer on the dishwasher would be programmed to run anytime between midnight and 5 a.m., depending upon when there's a surplus of energy. And the dishwasher's computer, I can already see this being a $5,000 dishwasher, um, would would use the smart grid system to determine the optimal time. All right. So, in terms of electricity availability to turn on the appliances, the smart grid system could help manage electricity demand so that the peak load time is not become too great when people come home from work. All right, we cannot control the timing of electricity demand. So that's something that we can't have. People get off work at 5, everyone gets home, demand goes up. But by improving the consumer awareness of electricity abundance and its shortages using like a smart grid appliance system and setting these variable pricings for electricity, we can make electricity use much more regular and regulated and thus more sustainable. So, our current electrical infrastructure relies on a system of large energy producers, like these regional electricity plants and stuff. So, when one plant goes offline or shuts down, then the reduction in available generating capacity puts a greater demand on the whole rest of the system. So, some energy experts say that a better system would consist of a large number of small scale electricity generated, like parks almost, and they rely on a mixture of things like fossil fuels and renewable energy sources. So, these experts maintain that a system of decentralized energy parks would be at least the least expensive route to go. And it'd also be the most reliable because the infrastructure would be mixed up and variable. I guess is what they're trying to say. Well, I guess these decentralized generators of electricity would also be less likely to suffer breakdowns and sabotage, since each small energy park might serve only a few thousand people, then these outages and things could be less likely. We need to address the energy cost and storage issue. These major impediments to this widespread use of wind, solar, tidal energy, and all these forms of renewable energy with the least amount of environmental impact are cost and the limitations of the energy technology worth it? I mean, fortunately, the cost of renewable energy has been falling, right? So, some markets where wind energy is now cost competitive to natural gas and coal, people can choose that over the other. But the production process becomes dramatically more efficient as more companies get involved and as technology becomes more developed. So clearly, there is a payoff for this technology.